The snow outside the train window came down in slow, heavy flakes, drifting across the barren fields of southeastern Michigan. It was the final days of December, in the first winter after the attack on Pearl Harbor. The train car was filled with a collection of men who only months earlier had been clerks, machinists, and farmhands. Their military uniforms had not yet arrived. They clutched their newly issued ration books, train tickets, and small government pamphlets that explained without much clarity where they were going and why. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed because tomorrow I've saved something extra special for you. One young man, barely 22, pressed his forehead against the glass as the train slowed. The conductor called the stop Ypsilanti Township. Outside, beyond the rail spur, the men saw only darkness and the faint outline of a building, an impossibly long structure, dominating the horizon. To many, it looked like a factory designed for an entire city. Floodlights illuminated the snow-swept expanse. The wind carried the metallic scent of freshly cut steel. This place had only recently begun to exist, born from drawings and concrete poured in haste. But soon, it would become known as the Willow Run bomber plant. The young man stepped down into the cold and felt a moment of disbelief. Inside those walls, he had been told, Ford intended to build B-24 Liberator bombers faster than any plane had ever been built, one complete aircraft, roughly every hour. At that moment, it seemed impossible. Even the experts said so. The B-24 was one of the most complex machines of the War 4 engines, a wingspan of more than 110 feet, a labyrinth of hydraulics and electrics, defensive armament, precision-machined components, and thousands of individual parts. Before the war, building just one bomber could take weeks. The thought of producing one every 63 minutes sounded like the boast of a madman. Yet, inside Willow Run, through the roar of presses and the vibration of conveyor tracks, Ford engineers and thousands of new factory workers were attempting to turn that bold declaration into physical reality. It raised a question that would soon reverberate across the Atlantic. How could a nation still emerging from the grinding poverty of the Great Depression possess the capacity to build warplanes with such relentless speed? The story begins not in Michigan, but in Europe, where German military planners had long believed that American industry was a sleeping, lethargic beast, technically impressive perhaps, but unorganized, scattered, and uninterested in war. The Germans saw themselves as the masters of precision. Their engineers spoke proudly of hand-fitted components and craftsmanship. In their minds, a weapon was a creation of artisanship, slow, deliberate, and deeply technical. American mass production, by contrast, was derided as crude. German officers studying the American economy in the 1930s routinely concluded that the United States lacked the discipline or central planning needed to convert peacetime industry into sustained wartime output. Germany had rearmed carefully, methodically, bending its economy around the requirements of total war. The United States, meanwhile, still built automobiles for private use and refrigerators for comfortable homes. At the start of the European conflict in 1939, American aircraft production was modest. In that year, fewer than 3,000 military aircraft rolled out of US. Factories, mainly fighters and basic trainers, not heavy bombers. The Luftwaffe, meanwhile, already blanketed the skies of Europe. German intelligence reported that America lacked both the urgency and the infrastructure to rival German air power. But events would soon challenge that assumption. In London, as German bombs crashed into the city night after night during the Blitz, British leaders dispatched urgent pleas across the Atlantic. They needed planes, large, long-range bombers that could strike deep into German territory. The United States Army Air Corps had already designated one such aircraft, the consolidated B-24 Liberator. With 4 Pratt & Whitney engines and a distinctive high-mounted Davis wing, the B-24 offered tremendous range and payload capacity, yet building it remained slow and largely manual. At Consolidated's San Diego plant, workers fashioned fuselage sections outdoors because the factory lacked indoor space. Temperature swings warped sheet metal. The lack of standardized jigs and precise assembly methods meant each B-24 was something of a custom job. Even when the war in Europe raged intensely, the process remained closer to a craft than a production system. Charles Sorensen, a senior Ford production executive, and the man who had once helped design the Model T's assembly line, visited San Diego in early 1941. He watched crews make adjustments with hammers and eyeballed fittings. He observed the absence of blueprints, standardized measurements, and coordinated sub-assembly lines. In his words, it resembled automobile work from the early 20th century before Ford revolutionized production. Sorensen returned to Michigan with sketches scrawled on hotel stationery. He envisioned a plant that would treat bomber production like automobile manufacturing, break each bomber into major components, build them separately, then converge them into a single final assembly line. The plant would operate as a synchronized machine. A fuselage midway down the assembly line would be joined by wings coming from another direction, tail assemblies from another, engines from yet another. Workers would not build bombers, they would assemble them. Still, this idea seemed like fantasy to many. Aircraft demanded far tighter tolerances than automobiles. Parts could not simply be bolted together like body panels on a car. They required precise alignment to endure high-altitude flight, combat stress, and long operational range. Yet Sorensen believed that with the right machinery, precision jigs, gauges, and digital-era equivalent standardization, mass production of aircraft could become reality. Ford's commitment to industrial discipline was unmatched. From the early 1900s onward, Henry Ford had insisted that efficiency was not simply a method, but a belief system, a way of understanding the world. But Henry Ford himself initially resisted building bombers. He disliked the idea of war production and feared that government contracts would smother the independence he cherished. His son, Edsel Ford, and Sorensen ultimately convinced him that the American automobile industry carried a responsibility to the nation's survival. By the spring of 1941, the architectural drawings for Willow Run were finalized. The building would stretch more than a mile end to end and cover millions of square feet, making it among the largest enclosed factory spaces ever constructed. Railroad spurs cut directly into its interior. Overhead cranes, each capable of moving massive assemblies, ran the length of the hall. Concrete crews worked through freezing nights to meet deadlines. Steel trusses arrived from mills in Pennsylvania and Ohio, traveling night and day along newly cleared road corridors. The building grew so large a special water system was required to maintain pressure across the entire structure. Workers in nearby towns stared at its rising walls with astonishment. Willow Run was to be a factory born not from incremental planning, but from national necessity, constructed with a pace that defied conventional wisdom. And yet, when construction first began, no one, not even Sorensen, could say with certainty whether the idea would actually work. Even before December's tragedy in Hawaii, President Franklin Roosevelt had recognized the urgency of air power. In a radio broadcast in late 1940, known as the Arsenal of Democracy speech, he declared that American factories must supply the Allies with the material to defeat tyranny. He did not speak of sending soldiers overseas, but of building machines, planes, tanks, and ships so numerous that no aggressor could match them. His words resonated deeply with industrial leaders. After Pearl Harbor in December 1941, the nation mobilized in earnest. The War Production Board, led by Donald Nelson, gained unprecedented authority. It could halt civilian production, divert raw materials to prioritization, and essentially determine the direction of the entire U.S. industrial system. Automakers found their showrooms empty not by choice, but by decree. Civilian vehicle production ceased by early 1942. Factories that had once made consumer goods now served a single purpose: build the three weapons that could win the war. But building B-24s was an especially formidable challenge. Each aircraft required over 450,000 individual parts, thousands of precision rivets, intricate hydraulic systems, and electrical wiring spanning the length of the plane. The bombers weighed more than 30 tons. Their aluminum skins were thin, demanding structural strength from internal spars and ribs. Assembling them without error was difficult, even under controlled conditions. Willow Run workers, however, were not aerospace craftsmen. Many had never worked in a factory at all. Some had come from rural farms, others from small offices, women who had never been offered industrial work, older retirees returning for the war effort, and young men not yet called into military service. Their training lasted weeks, sometimes mere days. Yet each would soon be expected to perform precise tasks demanding consistency and absolute attention to detail. Preparing and narrating, this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now back to the story. The true genius of Willow Run lay not in the workers' existing skill, but in how the factory taught them. Each workstation was broken down into individual tasks. A new worker learned to drill rivet holes at precise distances. Another learned to install electrical lines along color-coded paths. Through training stations, repetition, and close instruction, workers internalized a routine that made them reliable specialists, experts not in building bombers, but in building their part of a bomber. This organization mirrored the structure first perfected in automobile plants. By dividing a complex product into predictable modular steps, the individual did not need to understand the whole, only their part of it. Meanwhile, the Germans watched American production reports with skepticism. Reports of new factories in Michigan and California were dismissed in Berlin as inflated or propagandistic. Senior officials, accustomed to limited facilities and complex artisanal work, believed facilities like Willow Run could not overcome the inherent complexity of building large aircraft. Even within the United States, doubts lingered. Bombers were not automobiles. No matter how many hydraulic presses and jigs Ford built, the B-24 remained a machine of extraordinary sophistication. Early attempts at mass production were chaotic. The first fuselage lines saw bottlenecks as sub-assemblies arrived out of sync. Wings completed ahead of schedule sat idle while fuselage frames remained behind. The learning curve was steep. Yet the principle proved sound. By mid-1942, the plant's internal systems became more refined. Specialized jigs ensured uniformity. Precision gauges replaced eyesight. The pace of assembly improved. Raw aluminum arrived by rail and moved into cutting and forming stations. Riveters worked in pairs, one inside, one outside, communicating with practiced taps. Engines from Pratt & Whitney arrived crated and ready. Gun mounts, bomb racks, landing gear assemblies all moved along their own paths toward the final assembly. Amid the relentless motion, workers found themselves becoming part of something larger. Although they might only fit a series of connections along a wing route or bolt down hydraulic components beneath cockpit flooring, they took pride in knowing that each action gave life to the bomber. They called it our aircraft, even if they never saw it fly. Outside the plant, snow continued to fall in the winter months of 1942. But inside, Willow Run burned with light. The roar of presses echoed day and night. Men and women arrived in 3 shifts, around the clock. The war waited for no one. As the machines grew more reliable, so too did the rhythm of production. The final assembly line began to move slowly at first. A fuselage, incomplete and skeletal, advanced on rails. Workers installed flight control surfaces. The wings arrived, and teams aligned spars to the fuselage with precise measurements. Tail assemblies followed. This was the collision between disbelief and reality, because now, for the first time, the B-24 was not being built as a singular masterpiece. It was being assembled like a product, reliably, repeatedly, predictably. And yet, as 1942 drew toward its close, the plant was still short of its ultimate goal. Ford executives knew that if Willow Run's promise were to become reality, the entire system would need to operate like a clock, sub-assembly lines feeding without interruption, parts arriving on schedule, and workers performing with steady, practiced consistency. There remained countless difficulties ahead, but those who had once dismissed the idea now stood in quiet awe. Something unprecedented was taking shape in the Michigan winter, an airplane factory built on the logic of the automobile, assembling war machines in a manner previously unimaginable. Soon, German intelligence officers would read reports claiming that the United States could produce a B-24 every hour. They would shake their heads and dismiss the numbers. The mathematics did not make sense. Such claims were surely exaggerations or outright lies. They did not yet understand the forces gathering inside Willow Run. They did not yet see the true scale of American industrial might, and the world did not yet know what would happen once the assembly line finally reached its intended pace. Germany's aircraft industry had been built on tradition. Their factories relied on master craftsmen who treated each airplane like a work of art, measured, tailored, and polished by specialists with years of experience. To them, airplanes were not products, but creations. Precision came from artisan skill, not industrial speed. So, when American planners spoke of building four-engine bombers like automobiles, German intelligence ridiculed the idea. They believed the United States lacked both the skilled workers and the political will to industrialize aviation. The very notion sounded like wishful thinking, even childish. But Ford had never been in the business of following European tradition. He'd spent decades proving that machines could be built faster, cheaper, and better when the process was broken into steps, and those steps flowed. The Model T wasn't assembled by master craftsmen. It was pieced together by ordinary men standing alongside a moving platform. If America could build millions of cars this way, why not bombers? The man who ultimately made this leap real was Charles Cast Iron Charlie Sorensen, Ford's tough, uncompromising production wizard. While others debated theory, Sorensen believed in motion continuous, mechanical, unstoppable. One night in late 1940, he sat at a hotel desk and sketched a radical idea on a notepad. A straight-through bomber assembly line, just like the cars. Thousands of precision parts would arrive at one end, and a finished war machine would roll out the other. That drawing became the DNA of Willow Run. Construction began in a field of Michigan farmland and rose at astonishing speed. Workers joked that the building was so large it created its own weather. When finished, it stretched across 3.5 million square feet, one of the largest factories ever built. The assembly line inside was nearly a mile long, so long that designers had to bend it into a massive U-shape so completed aircraft could exit facing the airfield. From above, Willow Run didn't look like a factory at all. It looked like a city, perfectly squared, breathing smoke and steam. Inside, it felt like a world unto itself. Parts entered in crates. Sections appeared from the ceiling. Wings travelled in quiet procession over the heads of workers, carried by conveyors that seemed to float on air. The impossible was being attempted, turning a hand-built aircraft into a mass-produced machine. Most Americans who arrived to work here were not craftsmen. They were farmers, store clerks, housewives, teenagers fresh from school. Many had never held a wrench, never touched aluminum, never even seen an aircraft up close. Yet Sorensen believed that if you broke every job into steps simple enough to master, anyone could help build a bomber. And he was right. These ordinary workers soon learned to rivet, to weld, to wire. A mother could spend her morning packing lunches for her children, then go to Willow Run and help construct a machine capable of flying halfway across the world to fight Hitler's Reich. The Germans never imagined such a thing. To them, a bomber was artistry. To the Americans, it became a process, and that difference would change everything. Soon, the line grew faster. What took European factories weeks was compressed into days. The river of aluminum became a river of wings, then fuselages, then entire liberators rolling, toward the airfield gleaming giants with 4 engines and the promise of war beneath their wings. Willow Run was no longer an experiment. It was becoming a machine all its own, one that fed on iron, rubber and sweat, and gave birth to bombers. The world was watching. Germany was listening. And no one, not even the engineers at Ford, yet understood just how fast that river was about to flow. At first, Willow Run struggled. The magnitude of the task was overwhelming. Thousands of parts, suppliers learning on the fly, workers arriving every week without experience, and a new design that seemed to change every time a problem surfaced. Early B-24 seconds rolled off the line, slowly, painfully slowly. Some couldn't even taxi properly without adjustments. Engineers cursed, supervisors shouted, and mechanics worked night after night, fixing mistakes born of inexperience. It was chaos disguised as progress. Ford had promised miracles, and Washington expected them, but the bomber was far more complicated than anyone in the auto world could have anticipated. A car needed thousands of parts. A B-24 needed more than 1 million. Many once believed it was a machine too intricate to be built by mass production at all, and Willow Run seemed to prove them right. Newspapers whispered that Ford had bitten off more than it could chew. Skeptics surfaced in Congress, rivals smirked, even the Army Air Forces grew nervous. But behind those doubts, a deeper transformation was happening slowly, quietly. Workers were learning. Processes were refining. Mistakes turned into lessons, lessons into routine, routine into speed. Piece by piece, hour by hour, Willow Run changed. Men and women who had never seen an airplane before now spoke the language of torque values and structural tension. Young ladies from Detroit could rivet aluminum seams straighter than some trained craftsmen in Europe. Old mechanics who once tuned farm trucks now installed Pratt & Whitney engines with astonishing precision. The factory began to breathe differently. Its heartbeat steadied. Production shifted from improvisation to rhythm. One by one, the liberators rolled faster. At first, it took a week to build a single bomber. Then days, then hours. Sub-assemblies began to arrive already complete, built at satellite plants feeding the great mother machine. Wings came finished. Tail sections rolled in on rail cars. Engines arrived ready to mount. What had once been built in place became built in flow. Ford applied lessons from the automotive line relentlessly. Anything that could be standardized was. Anything that could be simplified was. Jobs shrank from overwhelming tasks to small bites. Instead of a master craftsman installing an entire hydraulic system, 3 workers each fitted a specific component. Step by step, the bomber was conquered. Soon, visitors watched in disbelief as a Liberator, gleaming under factory lights, was tugged out through the giant rolling doors, its propellers polished, its bomb bay ready, its skin smooth and taut like a beast waiting to leap skyward. And just behind it, another. Then another. The line began to move with the steady confidence of an assembly line that knew its purpose. Willow Run was becoming exactly what Sorensen had envisioned. Not a factory, but a river of war machines. The Germans had always assumed that America's industrial strength was theoretical vast on paper, sluggish in reality. They could not imagine that a country of farmers and shopkeepers would mobilize themselves into an arsenal capable of drowning the Luftwaffe in aluminum. But the transformation was underway. Steel didn't just bend here, people did. Women in bandanas and overalls labored shoulder to shoulder with men recently arrived from abandoned farms. They joked, cursed, sweated, and worked through the night under glaring overhead lights. The war was oceans away, yet it breathed through the rafters at Willow Run. Every bolt was a silent promise to the boys who would soon fly these machines. Every rivet carried a whispered hope that fewer suns would need to fall. The once impossible goal came closer with each passing month. 1 bomber, every hour. It sounded like madness, but the river was accelerating, faster, smoother, unstoppable. The miracle was coming. By mid-1943, Willow Run had become more than a factory. It had become a symbol. Its sheer scale and speed were almost incomprehensible to outsiders. Visitors from the Army Air Forces, journalists, and even foreign dignitaries arrived with skepticism, leaving in awe. One plane rolled out of the factory every 63 minutes, an achievement that seemed impossible just 2 years earlier. The significance of this pace was profound. In Europe and the Pacific, every additional bomber meant more pressure on Axis forces, more missions flown, more cities and supply lines disrupted. One plant in Michigan was tipping the scales of a global war. The factory itself continued to evolve. Engineers tweaked jigs, redesigned assembly stations, and reorganized the workflow to eliminate wasted movement. Every worker became part of a larger choreography, a mechanical dance synchronized across acres of steel and concrete. The sub-assembly plants feeding Willow Run multiplied, creating a network of interdependent factories that stretched across Michigan and beyond. The people inside the factory understood their role. For many, it was a job, but for others, it became a mission. Their work was literal and symbolic, building the tools to fight tyranny while shaping history itself. Veteran mechanics, newly trained riveters, women who had never held a wrench, everyone contributed. The roar of presses, the clang of metal, the hiss of welding torches became a constant soundtrack of war effort. Outside the factory, the world began to notice. German intelligence reports finally acknowledged the threat posed by America's industrial mobilization. High-ranking officers who had dismissed Roosevelt's pre-war speeches as idle bravado were forced to confront reality. The sheer speed and volume of aircraft production defied their expectations. The notion that the United States could not compete in prolonged war evaporated in the face of Willow Run's output. The psychological impact was as significant as the material one. For the Allies, Willow Run was proof that American ingenuity and industrial power could be converted into decisive advantage. For the Axis, it became a symbol of a war they could not match, no matter their tactical skill or technological innovations. By 1944, the pace of production had reached a rhythm that was astonishing. Skilled laborers and new trainees alike moved with mechanical precision, the assembly line flowing like a living organism. Liberators left the factory fully armed and mission-ready, rolling onto rail cars destined for training fields, forward air bases, and theatres of combat across the globe. The consequences of Willow Run's efficiency were tangible. Missions once impossible due to limited aircraft became feasible. Strategic bombing campaigns gained momentum. The Allies were able to maintain air superiority in theatres, where previously they had been at risk of being outmatched. Each bomber represented not only steel and aluminum, but also lives saved, missions accomplished, and a psychological edge in a war that had been measured in attrition as much as strategy. The factory's legacy extended beyond the war itself. Willow Run demonstrated that mass production could be applied to complex military machinery without sacrificing quality, a lesson that would influence industrial and military planning for decades. It proved that human adaptability, when combined with innovative engineering and unwavering purpose, could achieve results that seemed impossible. As the war drew to a close, the liberators continued to roll off the line, each one a testament to the determination, skill, and perseverance of the people of Willow Run. The world had witnessed an industrial miracle, one that reshaped the very understanding of modern warfare. In the end, Willow Run was more than a factory. It was a story of belief transformed into reality, of doubt overcome by discipline, and of human ingenuity, achieving what once seemed beyond reach. The men and women who labored there never saw themselves as heroes, but history would remember their work as a decisive factor in the defeat of tyranny. Every rivet, every bolt, every hour of labor had contributed to a truth that resonated far beyond Michigan, that the power to change the world sometimes begins not on the battlefield, but on the factory floor. The long-term effects of Willow Run extended far beyond the production of B-24 liberators. After the war, the factory and its associated networks of sub-assemblies became case studies in industrial efficiency. Engineers, economists, and military strategists studied the methods developed there, analyzing how mass production could be applied not only to military hardware but to civilian industry as well. The lessons learned at Willow Run informed post-war manufacturing practices, shaping everything from automobile assembly to commercial aviation. For the men and women who had worked on the line, the experience left an indelible mark. Many had entered the factory unsure of their abilities, trained in weeks to handle tasks that once required years of apprenticeship. They emerged with a newfound confidence, skilled in welding, riveting, machining, and assembly at an unprecedented scale. Their work had not only contributed to victory, but also accelerated social changes, particularly for women and minorities who had taken on roles traditionally reserved for men. The psychological dimension of Willow Run's achievement was equally significant. For the Allies, it became a tangible proof of the United States' capacity to sustain a long, resource-intensive conflict. The Germans, who had once scoffed at Roosevelt's industrial promises, were forced to recalibrate their expectations. Intelligence reports and intercepted communications revealed their growing concern over American production. The narrative that had defined their strategy that material superiority could be matched or neutralized was shattered. Historians would later note that the factory exemplified a broader principle, that warfare in the 20th century was as much about logistics, engineering, and sustained production as it was about tactics and battlefield heroics. The B-24 seconds that rolled off Willow Run were not just planes. They were the physical embodiment of strategic foresight, human coordination, and industrial ingenuity. Even the very speed at which Willow Run operated became a lesson in psychological warfare. One bomber every 63 minutes sent an implicit message to the Axis powers. The Allies possessed an industrial capability that no conventional military maneuver could destroy. The sheer scale of output became a tool of deterrence, shaping enemy strategy simply through the promise of overwhelming supply. After the war, the facility's role evolved. Portions of Willow Run were repurposed for civilian industry, contributing to the post-war economic boom. Yet the memory of its wartime contribution remained vivid. Veterans of the factory recounted their experiences to historians, educators, and family members, ensuring that the story of Willow Run would endure not just in statistics, but in the human experiences behind them. The broader legacy of Willow Run was a subtle but profound transformation in how nations understood the relationship between industrial capacity and military power. It proved that victory could hinge on innovation in production, just as decisively as on victories in the field. The people who labored there, whether veteran mechanics or newly trained women riveters, were as much a part of the war's effort as the pilots who flew the planes they built. In the end, the story of Willow Run underscores a fundamental truth about World War II. The conflict was not only fought on battlefields but also on factory floors, in the minds of planners, and in the hearts of workers who committed themselves to an extraordinary task. The B-24 seconds that left Michigan each hour were more than machines. They were symbols of human adaptability, of collective effort transformed into strategic power, and of the quiet, relentless determination that ultimately tipped the balance of a global conflict. History remembers generals and admirals, pilots and infantrymen, but Willow Run reminds us that wars are won not just by those who fight, but by those who build. The factory's output, precision, and scale became a defining element of the Allied victory, a testament to what is possible when ingenuity, discipline, and purpose converge. Its legacy is a story of belief made real, doubt overcome, and the enduring truth that human endeavor, when organized with vision and skill, can reshape the course of history itself. Willow Run's story did not exist in isolation. It was part of a network of plants, supply chains, and logistical coordination that stretched across the United States. Steel from Pennsylvania, engines from Detroit, electrical components from Ohio, and aircraft instruments from New York all converged to create a continuous flow of assembly. The meticulous planning required to synchronize these disparate elements mirrored a military operation on a scale that few civilians had ever witnessed. Yet the scale and speed of production revealed something deeper. The industrial power of a nation could act as a decisive weapon in its own right, reshaping enemy calculations and strategic planning long before a soldier set foot on a battlefield. The psychological impact on American workers was profound. Many entered the factories with a sense of uncertainty, but as the B-24 seconds began to roll out at ever-increasing rates, they developed a tangible sense of pride and purpose. Their labor, often repetitive and physically demanding, became an act of national service. The rhythm of assembly lines, once designed for cars, now became a heartbeat of war, a pulse that communicated determination and capability. Labor unions, engineers, and management collaborated in unprecedented ways to maintain efficiency, reduce errors, and keep the production schedule on track. In a very real sense, the war was being waged with hammers, rivets, and riveted steel, as much as with guns, bombs, and tactics. Across the Atlantic, German military planners struggled to comprehend what they were observing. Intercepted intelligence reports highlighted the astonishing output at Willow Run, but skepticism lingered. Could it truly be possible to build a heavy bomber every hour? When Allied bombing campaigns increased, the German command saw not just material losses but an operational reality. Even massive attacks could not cripple American industrial capacity. The speed and scale of production became a force multiplier, making each Allied sortie more effective simply because reinforcements were already on the assembly line. The factory also demonstrated an early instance of what would later be called lean manufacturing. Though not formally defined at the time, the principles of subassembly, standardization, and continuous workflow were applied with mathematical precision. Engineers analyzed every step, measured every movement, and optimized each operation to reduce waste and increase throughput. This industrial discipline, born of necessity in wartime, later influenced post-war industry worldwide, from automobile plants in Japan to aerospace production in Europe. Willow Run also highlighted the intersection of technology and human skill. Machines alone could not sustain the pace. They required trained operators, supervisors, and quality control personnel. In this context, human ingenuity became inseparable from mechanized processes. Workers adapted, learned, and innovated, solving problems in real time as bottlenecks appeared or materials failed to arrive on schedule. The result was a dynamic system that was both rigid in its structure and flexible in practice, a paradox that epitomized the ingenuity of the Allied industrial effort. Perhaps most importantly, Willow Run reshaped the narrative of capability and expectation. The Germans had assumed, as had many others, that wartime production was constrained by pre-existing limits: factory size, workforce skill, material availability. Willow Run proved that vision, leadership, and coordination could overturn these assumptions entirely. One bomber every 63 minutes became not just a statistic, but a statement. The United States had transformed its industrial landscape into a weapon of unprecedented power. By the end of the war, Willow Run had produced thousands of B-24 Liberators, each one a testament to the collaboration of engineers, laborers, and planners. The planes themselves were only part of the story. The real achievement was the system that made such production possible. The lessons of Willow Run about organization, speed, adaptation, and the marriage of human skill with mechanical precision would echo long after the last bomber had flown. In the broader sweep of history, Willow Run reminds us that wars are shaped as much by factories and assembly lines as by frontline strategy. The story of one plant in Michigan underscores the immense, often invisible, effort required to transform resources, labor, and ingenuity into decisive action. It illuminates the ways in which human determination, when directed with clarity and vision, can overturn assumptions, overcome doubt, and achieve what once seemed impossible. The B-24 seconds that left Willow Run were not merely tools of war. They were symbols of industrial might, collective effort, and the profound capacity of organized society to meet a challenge that demanded nothing less than total commitment. The impact of Willow Run extended beyond the war itself. After 1945, as peace returned, many of the techniques and organizational principles developed in its halls were adapted for civilian industry. Engineers and managers who had overseen continuous production lines for B-24 seconds returned to automobile factories, aircraft manufacturers, and machine shops, bringing with them a new understanding of efficiency, standardization, and large-scale coordination. The legacy of Willow Run was not measured only in bombers, but in the lasting transformation of American manufacturing culture. For those who had worked in the plant, the experience left an indelible mark. Men and women, many of whom had never touched a rivet gun or operated a stamping press before the war, discovered the extraordinary capabilities within themselves. Their contribution was not romanticized in newspapers or propaganda posters. It was real, measurable, and undeniable. The lines of aircraft stretching across the enormous factory floor stood as a visible proof that ordinary labor, when organized and applied with purpose, could achieve the extraordinary. Willow Run also embodied the strategic foresight of American leadership. By investing in infrastructure, streamlining logistics, and standardizing production, the United States ensured that material superiority would become a decisive factor in the outcome of the conflict. The factory's output provided more than planes, it provided leverage. The presence of vast numbers of B-24 seconds in the skies over Europe and the Pacific altered German and Japanese calculations, forced tactical adjustments, and accelerated the erosion of Axis capacity to wage war. Production, in this sense, became strategy. The story of Willow Run underscores a recurring theme in military history: the often invisible power of preparation and logistics. While battles, tactics, and heroic deeds dominate public memory, the underlying machinery of war, the factories, railways, ports, and supply lines, frequently determines the limits of what armies can achieve. Willow Run stands as a quintessential example of this principle. Without it, the Allies would have struggled to maintain the tempo of their air campaigns. With it, the United States not only kept pace but surged ahead, reshaping the war in ways that were only visible when the results appeared on the battlefield. The Germans' astonishment was well-founded. Intelligence reports and captured documents reveal that they simply could not comprehend the scale and speed of American production. One bomber every 63 minutes, achieved through a combination of industrial ingenuity, disciplined labor, and meticulous planning, shattered assumptions about the limits of human and mechanical productivity. It was a practical demonstration that technological capability, when combined with organizational excellence, could become an instrument of national power that rivaled and often exceeded the skill of even the most disciplined armies. Ultimately, Willow Run was more than a factory. It was a symbol of what could be accomplished when vision, leadership, and human effort converged. It reminds us that the outcome of wars, and indeed the arc of history itself, can hinge on factors far from the front lines. The people who worked, planned, and solved problems in Michigan created effects that resonated across oceans, shaping the strategies of adversaries and ensuring that the industrial might of one nation could decisively influence the course of a global conflict. Reflecting on Willow Run, one sees not only the story of production but the story of belief overturned. A nation underestimated, doubted, and dismissed as industrially incapable, the United States demonstrated that with ingenuity, determination, and coordination, what seems impossible can become reality. Every B-24 that left that plant carried with it not just bombs, but the lesson that human potential, when structured and mobilized, can transform uncertainty into decisive advantage. In the final measure, Willow Run stands as a testament to collective effort, disciplined innovation, and the extraordinary consequences of ordinary labor applied to a monumental challenge. Its story reminds us that history is made not only in the heat of battle, but in the quiet, precise, relentless work of those who transform tools, steel, and ideas into instruments that change the world. Up next, you've got two more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.